Good morning students. In part B, solved problems, essay questions. We have 16th problem. Verify that 3 minus 1 minus 1 by 3 are the zeros of the polynomial, cubic polynomial. P of x equal to 3x cube minus 5x square minus 11x minus 3, and verify the relationship between zeros and quotients. This problem will have two parts, part A and B. Part A is verify that 3 minus 1 minus 1 by 3 are the zeros of this polynomial. Next part B is verify the relationship between zeros and quotients. Now we will take part A. What is part A? Solution to part A. Solution. Now we have to verify P of 3 minus 1 minus 1 by 3 are the zeros of the polynomial. Now we have to substitute in place of x 3, so that we should get P of 3 is equal to 0. Then we can say 3 is the zero of the polynomial. See, substitute P of 3. In place of x you substitute 3, because P of 3 is the remainder. If you get P of 3 is equal to 0, remainder is equal to 0, then we can say 3 is the zero of the polynomial. Now 3 into, in place of x I am substituting 3, cube minus 5 into 3 square minus 11 into 3, in place of x I am substituting 3 minus 3. Now implies P of 3 is equal to 3 cube means 27, 27 into 3 81, minus 3 square means 9, 9 5s are 45, minus 11 3s are 33, 33 minus 3, 81 minus 45 minus 45 minus 33, minus 78, minus 78 minus 3 minus 81, 81 minus 81 0. Then you got P of 3, you got here P of 3 is equal to remainder. P of 3 is the remainder. Remainder you got 0. Then you can say 3 is the zero of the polynomial by factor theorem. Now implies 3 is zero of polynomial P of x. This is the 3 is the zero of the polynomial. And also you can write x minus 3 is factor of P of x. Now next I will take P of minus 1. Substitute here. Now P of minus 1 I am taking, instead of x I am taking minus 1. We have to show that minus 1 is the zero of the polynomial. We have to show P of minus 1, that is remainder is equal to 0. Then we can say minus 1 is the zero of the polynomial. You substitute 3 into minus 1 whole cube minus 5 into minus 1 whole square minus 11 into minus 1 minus 3. Minus 1 cube means minus 1. Minus 1 into 3 minus 3. Minus 1 square means 1. Minus 1 into minus 1 1. 1 into minus 5 minus 5. Minus into minus plus 11 into 1 11 minus 3. Now you see minus 3 minus 5 minus 8 minus 8 minus 3 minus 11 minus 11 plus 11 is equal to 0. As we got P of minus 1, P of minus 1 is a remainder, is equal to, you are getting 0. You can say minus 1 is 0 of polynomial P of x. Then you can say, now also you can write x plus 1 is factor of P of x. Now P of x we have 3x cube minus 5x square minus 11x minus 3. What is the polynomial we have? 3x cube minus 5x square minus 11x minus 3. We have to substitute in place of x, we have to substitute minus 1 by 3. We have to show p of minus 1 by 3 is equal to 0. 3 into minus 1 by 3 whole cube, 5 into minus 1 by 3 whole square, minus 11 into minus 1 by 3 minus 3. Now 3 into minus 1 by 3 whole cube, minus 1 by 3 into 1, minus 1 by 3 into 1, minus 1 by 3. You will get minus 1 by 27. 3 cube means 27. Minus 1 by 3 whole square means plus 1 by 9. 5 by 9 you are getting. Minus into minus plus 11 by 3 minus 3. 3 ones are 3 nines are. Minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. I am taking 9 LCM minus 1 minus 5. 3 3s are, we have to multiply with 3. 11 3s are 33 minus 9 3s are 27. You see, minus 1 minus 5 minus 6. Minus 6 minus 27 minus 33. Minus 33 and plus 33 by 9. Plus 33 minus 33 cancel. 0 by 9. 0 by 9 is equal to 0. Yes, we got p of minus 1 by 3 is equal to 0. Therefore, minus 1 by 3 is 0 of polynomial p of x. And also you can write here, x plus 1 by 3 is the x plus 1 by 3 is factor of p of x. Part A is over. Verify 3 minus 1 minus 1 by 3 are the zeros of this cubic polynomial. We have substituted 3. We got remainder as 0. Then we can say 3 is the 0 of the polynomial. Like that, minus 1, p of minus 1 we have substituted in place of x. We got 0 remainder. Then we can say minus 1 is the 0 of the polynomial. Minus 1 by 3 also we got 0. Minus 1 by 3 is the 0 of the polynomial. Next, this is part A. Verify zeros of the cubic polynomial. Yes, they are zeros of the cubic polynomial. This is part A is over. Part A is over. Now what is part B? And then verify the relationship between zeros and quotients. Now what we have to do? We have to verify the relationship between zeros and quotients. What are the quotients here? 3 minus 5 minus 11, 3. Now see, p of x, it is in the form of ax cube plus bx square plus cx plus d. A is not equal to 0. A, B, C, D belong to real numbers. What is A here? 3. A is equal to 3. What is B here? B is equal to minus 5. What is C here? Minus 11. You see, 11. Don't write 11. You have to write minus 11. D is equal to minus 3. We compared the coefficients. Comparing the coefficients. We know these are the coefficients. Now we have to verify the relationship between zeros and coefficients. How can we verify? First you have to take sum of zeros. First, sum of zeros. What is sum of zeros? Alpha plus beta plus gamma is equal to minus b by a. What are these alpha, beta, gamma? First, let alpha, beta, gamma are the zeros of this polynomial. We have to write let alpha, beta, gamma are zeros of polynomial p of x is equal to 3x cube minus 5x square minus 11x minus 3. we have to take alpha, beta, gamma or zeros of this given cubic polynomial. Then what is the relationship between zeros and coefficients? Sum of zeros is equal to minus b by a. See, you take LHS, you take all. What is alpha here? 3. What are alpha? What is alpha? Alpha, beta, gamma. Alpha is equal to 3, beta is equal to minus 1, gamma is equal to minus 1 by 3. We know. What is alpha, beta, gamma? 3 plus, I am taking LHS. We have to prove LHS is equal to RHS. Sum of zeros and relate. This is coefficients. 3, what is it? Minus 1 plus minus 1 by 3. First I will take LHS. 3 minus 1. 3 plus into minus, minus 1. Plus into minus, minus 1 by 3. Now you got 3 minus 1, 2. Minus 1 by 3. What is the LCM? You got 3. 3 2s are 6. 6 minus 1. That is, you got 5 by 3. What is the LHS you got here? 5 by 3. I will take RHS. What is RHS here? Minus B by A. What is minus? What is B here? Minus 5 by, what is A here? You see, A is 3, B is minus 5. By A is 3. Minus into minus plus 5 by 3. You see, LHS is equal to RHS. You got the same. We verified sum of zeros and these are the coefficients. This is over. Next I will take 2. Sum of the product of zeros taken 2 at a time. At a time means, you know, alpha, beta, beta, gamma, gamma alpha is equal to, what is the formula you have? C by A, alpha, beta. You have to remember the formula so that it is very easy for you. Say alpha, beta, beta, gamma, gamma alpha is equal to C by A. Now I will take LHS. What is LHS here? Alpha, beta. Alpha, what is alpha here? 3 into minus 1. 3 into minus 1 plus beta, gamma, minus 1 into minus 1 by 3 plus gamma alpha means minus 1 by 3 into 3. This is LHS. Minus 3, minus into minus, plus 1 by 3. 3 3 cancel. You are getting minus 1 here. Say minus 3 minus 1, minus 4. Minus 4 plus 1 by 3. You take LCM 3. You got 3 4s are 12, minus 12 plus 1, minus 11 by 3. What is LHS? LHS I got minus 11 by 3. RHS also, it should be equal to minus 11 by 3. What is C here? Minus 11. C is minus 11 by, what is A here? 3. You see, A is equal to 3. Yes, this is RHS also I got minus 11 by 3. LHS is equal to RHS. You write LHS is equal to, left hand side is equal to right hand side. We verified sum of the product of zeros taken at a time, that is alpha, beta plus beta, gamma plus gamma alpha is equal to coefficients C by A. They are equal to each other. We verified. Last one, third one, product of zeros. Product of zeros. What is the product of zeros? Zeros are alpha, beta, gamma. Alpha into beta into gamma. Alpha, beta, gamma is equal to minus D by A. Now I will take LHS. This I will take. Alpha, beta, gamma. You have to multiply these 3. 3 into minus 1 into minus 1 by 3. 3 cancel, minus into minus plus. You should get minus into minus plus 1 I got. Then RHS also you should get. What is RHS? Is equal to RHS. I will take RHS. What is it? Minus, what is D here? Minus 3. D is minus 3 by, what is A here? A is 3. Minus into minus plus, 3 cancel, 1 you are getting. LHS is equal to RHS. What is 17th problem? Find the zeros of the polynomial p of x if two of its zeros are minus root 2 and root 2. Has given two zeros, minus root 2 and root 2. If minus root 2 is a zero of that polynomial p of x, then you can say x plus root 2 is the factor of that polynomial by factor theorem. And also you see, what are the factors? See, minus root 2 is 0 of p of x. Then you can say x plus root 2 by factor theorem. X plus root 2 is factor of p of x. Then root 2 is the zero of the polynomial. Then you can say x minus root 2 is the factor of p of x, and root 2 is 0 of p of x. Then you can say implies x minus root 2 is factor of p of x by factor theorem. What are the factors? X plus root 2 into x minus root 2. Factors of p of x. What are the factors? X plus root 2 and x minus root 2. Product of the factors. Product of the factors of p of x is equal to x plus root 2 into x minus root 2. X square minus 2. A plus b into a minus b. A square minus b square. Like that. X plus root 2 into x minus root 2. X square minus root 2 whole square means 2. X square minus root 2 whole square means x square minus root 2 whole square means 2. X square minus 2 is the product of the factors. Now, to get other factors, to get other zeros, we have to divide this polynomial with x square minus 2. X to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. I will divide it with x square minus 2. Means x square minus 0 into x minus 2. X square minus 0 x minus 2. I have to divide it with x square. X term is not there. That's why I am taking x square minus 0x minus 2. Now already 2x to the power of 4 by x square. You have to multiply with 2x square. 2x square into x square, 2x to the power of 4. 2x square into 0x, 0x cube, 0x cube. 2x square into minus 2, minus 4x square. I am subtracting this from this one. Plus becomes minus, minus plus. 2x to the power of 4 minus 2x to the power of 4 cancel. Minus 3x cube remaining minus 3x square plus 4x square. plus x square. Take down plus 6x. Now minus 3x cube by x square. We have to multiply with minus 3x. Minus 3x into x square minus 3x cube minus 3x into 0, 0, 0x square, 0x square, minus into minus plus 3 to the 6x. Minus, subtracting this from this. Minus becomes plus, plus becomes minus. Plus 3x cube minus 3x cube cancel. Plus x square 0 means x square, you are getting x plus 6x minus 6x cancel. Now take down minus 2. See, x square by x square, you are getting 1. You have to multiply with 1 plus 1. 1 into x square, 1x square, 1 into 0, 0, 1 into minus 2, minus 2. Subtracting this from this, plus becomes minus, minus becomes plus, plus x square minus x square cancel, minus 2 plus 2 cancel. What is the remainder you are getting? Remainder is 0. Now you write p of x is equal to what is 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. It can be written as, already we have the product of the factors, x square minus 2. This is g of x and this is q of x and this is remainder. See, you got remainder 0. The product of x square minus 2 and 2x square minus 3x plus 1. X square minus 2. I am factorize here. I am factorizing 2x square minus 3x plus 1 because we have to find the other zeros also. We have 2 zeros. We have to find other 2 zeros. It is a quadratic polynomial. You can find out 2 zeros. Say 2x square minus 3x plus 1. 1 into x square, 1 into 2x square, 2x square. 2. It can be written as 2 into minus 2x minus x plus 1. 2x common, you take 2x common, you are getting x plus 1. X minus 1 you are getting. Minus 2x into x square, 2x square. 2x into 1 minus 2x. You take minus 1 common here. You are getting x minus 1. X minus 1 is common. X minus 1 is common. What is the remaining one? 2x. What is the remaining one here? 2x minus 1. Now it can be written as x minus 1 into 2x minus 1. Now this is p of x. Now I have to find the zeros. What is zero polynomial? The value of x for which p of x is equal to 0. See, equated to 0 implies 0 is equal to x square minus 2 into x minus 1 into 2x minus 1. X square minus 2 is equal to 0. How many zeros? X square minus 2 is equal to 0. X is equal to minus root 2. You see, it can be written as x plus root 2 into x minus root 2 is equal to 0. X is equal to minus root 2. X is equal to root 2. You got 2 zeros. Anyway, he has given 2 zeros. Now we have to find other zeros. X minus 1 is equal to 0. This is 1 0, 2 0. X minus 1 is equal to 0. X is equal to 1. Third 0. What is another remaining? 2x minus 1 is equal to 0. 2x is equal to 1. X is equal to 1 by 2. This is x4. Now how many zeros? x1 minus root 2, x2 root 2, x3, what is the 0 you got? 1, x4, last 0, 1 by 2. Like that, we have, as it is a biquadratic polynomial, the degree of the polynomial is 4, then it will have 4 zeros, minus root 2, 1 and 1 by 2. Already I gave two of the roots, minus root 2 and root 2. We found 1 and 1 by 2 are other zeros. Okay.